National Instruments LabVIEW graphical software is the standard for test, design, and control applications. A recent application employed LabVIEW's graphical approach for improving the once painful treatment of retinal diseases. Without a VHDL programmer, Optometrica used LabVIEW and NI hardware to replace a single manually targeted laser with multiple precisely controlled lasers. This increases accuracy and reduces both pain and treatment time for patients. From kindergarten to rocket science, what can you do with LabVIEW? The European Organization for Nuclear Research, or CERN, is the world's largest particle physics laboratory. Near Geneva, on the border between France and Switzerland, CERN engineers are building the world's largest particle accelerator, the Large Hadron Collider, or LHC. Scheduled to go live in May 2008, scientists are expecting the LHC to recreate the conditions just after the Big Bang to answer questions about the very origin of the universe. The LHC is a circular accelerator 27 kilometers around in which two beams of protons travel in opposite directions near the speed of light and collide to form new particles. The energy of each beam can reach 350 megajoules, enough to melt 500 kilograms of copper. Engineers at the LHC are developing special devices called collimators to redirect stray particles from the beams and prevent them from damaging the collider.
We have to move the LHC collimators with a very tight accuracy of 20 microns because it has to be a fraction of the dimension of the beam, which is only 200 microns. And this has to be done synchronously all over the 27 kilometers.
To meet these strict timing, accuracy, and reliability requirements, CERN chose a motion control and feedback system based on reconfigurable I/O and LabVIEW FPGA. They selected PXI for the deployment platform due to the small size and cost savings over the traditional VME and PLC-based model. LEGO Mindstorm's NXT is a new way for kids of all ages to build and graphically program robots. Powered by National Instruments LabVIEW graphical software, LEGO Mindstorms opens up robotics to a whole new generation of future engineers and scientists. Using LabVIEW for a programming and design platform enables children to easily understand programming concepts without limiting the potential of their creations. From kindergarten to rocket science, what can you do with LabVIEW?
Ormen Lange is a natural gas field located off the coast of Norway and has the potential to produce around 20 billion cubic meters of gas every year. Hydro, one of the world's leading energy suppliers, is the operator for the Ormen Lange project and faces several daunting obstacles. First, the Ormen Lange gas reservoir is located at a depth of 3,000 meters below sea level and buried by very unforgiving terrain. Once at the surface, the gas must be transported through pipes along the seabed, but because of the uneven terrain, the ocean floor must be leveled in order to prevent undue stress on the pipes. In order to meet the challenges presented by Ormen Lange, two remote-controlled underwater excavating machines have been developed by Nexans. The required gas pipeline will be 1,200 kilometers in length, and these spiders will be used to excavate and level the seabed before any of the 100,000 pipes are put into position. The spider is controlled using 3D software developed with National Instruments LabVIEW. The operator has complete overview of the spider through a series of LabVIEW screens and live video from cameras located on the exterior of the spider. The excavation process is displayed in a 3D ActiveX control on the LabVIEW front panel. The controller operates the spider from onboard a ship using a joystick. 3 distributed compact Rio systems from National Instruments are used for heave compensation, winch control, and power control, as well as communication with the main LabVIEW applications. Nexans was able to develop a system that is easy to maintain due to the consistent programming paradigm for both HMI and embedded control.
Darwin, a dynamic anthropomorphic robot with intelligence. Developed at the Robotics and Mechanisms Lab, ROMELA, at Virginia Tech, Darwin uses a robotic system developed using technology from National Instruments. An initial design study was performed on Darwin 0 to see how LabVIEW would interface with the servo motors of the robot. LabVIEW is controlling the robot shown over a serial RS-485 network. With great ease, LabVIEW can make the robot stand up and even walk. However, this robot does not use any sensors or feedback. The result? Using LabVIEW software, the robot identifies and then locates the relative position of an object, in this case a ball. This software was made by just one student with no prior experience to any vision processing in just 2 hours using LabVIEW Vision. In just 1 week, one student developed behavior control that allowed Darwin to play soccer and qualify as the only U.S. humanoid robot for the International Autonomous Robot Soccer Competition, RoboCup. Other teams spent years with many students writing in C code to accomplish the same task.